Let's think about this Argan plane of complex numbers. You have the number 0 here, you have positive real numbers 1, 2, 3 here, negative real numbers -1, 2, -3. You have imaginary numbers iota, 2 iota, and you have all the numbers in between here. So these are all the numbers which we use and we think about in mathematics. And in general, any number is a complex number. So I will think about some simple complex numbers like 1 plus iota, 2 iota, and -1 plus iota. And I would like to think about the meaning of arguments. So I have chosen these simple numbers because the angles which will be used here will be simple. For example, how much is this angle? If this is 1 plus iota, this distance is 1, and this distance is also 1, right? So because of that, this is 90 degree. Because of that, this angle will be 45 degree because it's a right angled isosceles triangle. So similarly, this side you will have 45 degrees, and you have these lines, connecting lines. Okay, so we can say very simply that the argument of Z1, this complex number, is plus pi by 4. I think my viewers know about this thing because mostly in the textbook we see that argument of a complex number is defined first, and then we reach slowly towards more complicated expression of arguments. But I would like to make a very important point here. It's like the argument Z1, how is it defined? It's like you connect, it's not defined just by looking at this point Z1, right? You will have to see where the origin is. You will have to see where the real number axis, real axis is. That to positive real axis, not the negative real axis. So you'll have to think of this positive real axis. You'll have to join this complex number Z1 from origin, and then you have to think of this angle. And then if you move in a clockwise sense, you use negative sign to represent that angle, and in anti-clockwise you use positive. So because you see here, this we are moving anti-clockwise pi by 4, and that's why we have written this plus pi by 4. You can also add and subtract 2 pi or 4 pi and things like that, which is very trivial, that we can of course do. But my point is, when you write argument, look at this this thing inside. You can modify this as argument of, I can write Z1 as Z1 minus 0 by 1 minus 0, nothing changes. But this is how in general we should think about arguments in terms of 4 complex numbers, not just one. You see, we should think of arguments in terms of argument of Z1 minus Z2, Z3 minus Z4, and define this thing, this as some angle, not just argument Z1. So how do we think of this term here? Okay, so it's like you have Z1, you have Z2, 2 complex numbers, then 3 and Z4 anywhere, let's say here, and you think of the numerator Z1 minus Z2. So you see, you're going towards Z1 from Z2, Z1 minus Z2, like think of them like vectors. So if you have, let's say, R1 as a position vector of point 1 and point 2, and it has a position vector R2. So if you are going towards 1 from 2, then you write that position vector, let's say this is origin, then you write that position vector R1, 2 as you're going towards 1 from 2, R1 minus R2, right? R1 minus R2 will be this vector going towards 1 from 2. This you can check very easily because you add 0, 2 vector plus 2, 1 vector, and they should give you 0, 1 vector. So what is your 0, 2 vector? That is R2. And 2, 1 vector, what is this 2, 1 vector? From 2 towards 1, that is R1 minus R2, and this will give you R1. So how do you think about this term argument Z1 minus Z2 by Z3 minus Z4? So you think about this vector first, numerator vector, z1 minus z2 going towards z1 from z2. Then you think about the denominator vector going towards z3 from z4, and you think about these two vectors and you join their tails and then measure the angle between them. This is what this argument is all about. So I have these two vectors, and let's say this is my numerator vector, and then this is my denominator vector. So I will go towards the numerator vector from the denominator vector, and because I'm going clockwise, I will report whatever this angle is, let's say theta. I will say that the argument, this will be minus theta. Okay, and this way if you understand the argument of z1, you can also understand, you can write in terms of these four complex numbers this expression z1 minus 0 by 1 minus 0. So z1 minus 0, you will move towards z1 from 0, so this vector here, and you will move towards 1. Where is 1? This is this complex number 1 here. You will move towards 1 from 0. So this is your denominator vector, and this is your numerator vector. You will move from denominator vector towards the numerator vector by matching their tails first, and then you will move from denominator to numerator, and then you can see that this angle is pi by 4 anti-clockwise. That's why we are reporting it as plus pi by 4, right? So how about like in this diagram, how do you think about argument z1 minus z2 by z3 minus z2? So your numerator vector is z1 minus z2 going towards z1 from z2, so this vector here, and then denominator vector is going towards z3 from z2, this, and then you think about this angle. Their tails are already matched right here. So this angle here, this is clockwise, no, this is anti-clockwise, 90 degrees. This angle you can figure out, because this is pi by 4. All these right angle triangles here, they are right angle isosceles triangles. That's why this is 90 degree. So this will be plus pi by 2. You can also verify this result if you don't believe me. So you can verify by putting the values of z1, z2, z3 and z2 here, and then think about the argument of that complex number in the way the textbooks define argument of a complex number. I'll show you. So argument of, for z1 I will put 1 plus I minus z2 is minus 2i, and z3 I will put minus 1 plus I, and z2 is minus 2i. So this turns out to be the argument of iota, and iota is right here, and argument as defined of iota as defined in the textbook, from positive real you go towards this I, and you see this is anti-clockwise 90 degrees, which we have done without doing all these calculations, just by understanding what is the format in which we should think about argument and write arguments. How about this one? This is for my viewers. What do you think about this? What should be the answer here? I would also like to talk about how modulus is defined in textbooks, and then how it should have been defined in a more general way. So this same diagram here, what do you think about mod z1? So mod z1 is like, it's not defined on its own. That's not the property of this point only. You also have to think about the origin and the distance between origin and this complex number. So why not you write z1 as z1 minus 0? No? And of course this answer is root 2, but you can think of mod z1 as z1 minus z2. You can think of any modulus in terms of like z1 minus z2. And you can think about that this is the distance between z1 and z2, two complex numbers, because 0 is also a complex number, right? So mod z1 is like distance between z1 and 0. Mod z1 minus z2 would be distance between these two complex numbers, and then it will be easy. You don't have to do this whole algebraic calculation. You can simply see that these distances are root 2 in this diagram. So this will be also root 2. You can verify it by putting the values of z1 and z2, 1 plus I minus 2I. This will be 1 minus I, and this will be root 2. So I like to think in terms of like the more general expression of modulus and argument, and hope you would also have fun with these expressions. Thank you.